Now, in this video, we want to explain to you about the MCB, and I will open an MCB device and explain the components inside it. So stay with me. The widely used device for disconnecting and connecting electricity in the power circuit and common circuit is the MCB device. Here you can see the signal phase and the three phase. It is made in one and two four phase types. This MCB device protects the load or the motor against two factors. One part is open and the other is a short circuit. This is the three-phase MCB device that you see here. It works like this. Uh, it is a signal phase MCB device. As you can see, it is connected. The electricity input is connected from this part, and the bimetal is located here, and it is placed inside a coil from the bimetal part. This bimetal has the tags of disconnecting against overload, and this coil has the tags of disconnecting the load against a short circuit. And from this part, it is transferred to the output. Now, suppose that a short has a current and a large current follows through the coil. This current causes strong magnetic field and cut off the electricity from this part. And now we connect the K again. So now we have said that the short circuit has occurred and strong current follow through the coil. This current causes a strong magnetic field and cuts off the electricity from this part. In the second case, when we overload occur, a bimetal is located here. This overload causes the bimetal, the head of the end, the bimetal bends and the disconnection opens. If I hit this bimetal with a heater, the bimetal will create until it cut off the MCB switch. Now, since it is heated, we cannot connect it. We have to wait until it cools down and the connection is established. Now we can connect it the K again. Well, these two factors cause the MCB disconnection in the circuit. This MCB device is available in different types. Model B can be used between 3 and 5 times the rate current. Model C can be used between 5 and 10 times the rate current. Model D can be used between 10 and 25 times the rate current. So the model are separated from each other based on this. For example, model B is used for a household lighting loads. Model C is used for the small induction motors, and it is the generally used for general uses that have a starting current between 5 and 10 times the rated current. And the Model D is used from a large induction motors or a UPS or X-ray machine. So this MCB device works on a two bases: a bimetal located here and a coil that detects a short circuit fault, and this bimetal detects overload. Now, because the bimetal cold, this gap was created here, and now we can activate the MCB switch again. Now, this bimetal again. As it heats up, this distance decreases until the MCB switch cut off. Well, these are two use of this MCB device. This piece is a sprig transfer, and we can remove it completely, but it should be, because in the case of a short circuit, sparks will be occur inside the MCB, which must be eliminated with this device. And if this PC is not there, it will be because the MCB switch is